Okay, group. So, our unit 5, let's bring it together. Bring it together.
Oh, yeah.
Okay, our unit 5 is called linear modeling. So basically what it is it's using those straight lines. Like if you think about a graph, a linear function to model real life situations. So we're going to be taking real life stuff, writing equations from it, and using it to answer some questions. The first thing is, we have to figure out is what is the slope-intercept form of a line. Do you remember? Slope-intercept form? Y equals mx plus b. Y equals mx plus b. What does m stand for? M is the slope and b is the... Okay, now, when we think about y-intercept, what is the x value of a y-intercept? What's the x value? 0. Okay, so 0 and then some number. That is super important that you remember that the x value is 0 for the y-intercept. It's going to come back to us later. Okay, let's go ahead and put our cell phones away, please.
Can a hashtag be like the representation of like a number that's...
Yeah, it doesn't mean hashtag, it's number. Yeah. Okay, write the equation of a line. Write the equation of a line that has a slope of 1/2 and passes through the point 0,4. So this point 0,4, is that point special? What is that point? Yes, this is the y-intercept. So like I said, that point, they don't tell you it's the y-intercept. You have to know that based on the fact that it has an x value of 0. So if we were to write this equation, we would get 1/2 x plus 4. Y equals 1/2 x plus 4. Okay, number 2, write a linear equation relating x to y. It's just saying write the equation of y equals mx plus b. Do we know what the slope is?
20.
Just from looking at this, no. We need to find it. Do we know what the y-intercept is?
Yes.
Yes. How do we know what the y-intercept is? Where x is 0. There's your y-intercept. So your b value is going to be 20. We just don't know what the slope is yet. How can we find the slope? How can we find the slope?
Use 2
Stack and
points.
support.
Stack and subtract, or yeah, we're going to do slope formula. Okay, so if you look at what we have, okay, you can pick out any 2 points that you want. So I'll go ahead and use 0, 20, and 3, 8. Those will be my 2 points that I'm going to use. Okay, if you do stack and subtract, go for it. I'm going to go ahead and do the slope formula. So I would have 8 minus 20 over 3 minus 0. Oops. So that would be negative 12 over 3 for a slope of negative 4.
That is 1.
Y-intercept. So y equals negative 4x plus 20. That's our y equals mx plus equation. Okay, we okay on that? Questions, issues, concerns? All right. When we are using linear equations to model real-world situations, we have to kind of decode the word process. We have to know what are they telling us, like what information are they giving us. So look at example 1. A balloon is released from the top of a building. So imagine Mrs. Bass is standing on the top of the school, and I have a balloon in my hand, and then I release it. Okay? The graph shows the height of the balloon over time. So let's just kind of dissect the graph for a second. Okay? So I want you to think about if I'm standing on top of a building. Okay, so here's the building, and I'm standing up here. This is me. Okay, and I have a balloon in my hand. Okay, is there going to be an initial height that balloon is off the ground? Yes, it's going to be the height of the building plus me, correct? Okay. So if we go over to our graph, if you look at this initial height right here, it's 0.5. That kind of is a little weird for a distance. So let's look at context. Right here it says 1,000 feet. So if we take a half of 1,000 feet, what would that be?
500.
Okay, so the initial height of the balloon off the ground is
500.
500 feet. Are we tracking? Okay. So that's our y-intercept. Okay, now we won't put the feet in the equation part, okay, but the y-intercept is 500 feet. All right, our slope. So let's think about rise over run. So if I start here, right, and I go over and up, right, if I'm going up from 0.5 to 1.5, how many feet is that?
1,000.
1,000 feet. Remember, you have to think in context of your label there. And then I'm going over how many? It's one block, but how many units?
10.
10 what?
Seconds.
Seconds. Okay, now, I don't want you to just put 1,000 over 10 here. Let's go ahead and simplify that. What's 1,000 divided by 10?
100.
100. And that's 100 feet per second. Okay, so the equation of the line will be y equals 10x plus 500. So we take our slope, put it in front of x. We take our y-intercept, put it in there.
Yeah.
Oh, sorry. I meant to write 100. That's not what happened. There we go. That looks a little better. All right, let's interpret the y-intercept in context. We kind of already talked about it a little bit. Can anybody raise their hand and tell me what is that y-intercept in context of our balloon problem? The initial height of the balloon. Okay, what about the slope? This one we didn't really talk about too much yet. We do have a label on our slope, so that should kind of help give you a little bit of a hint. But can anybody raise their hand and tell us what that slope means in context of our problem? What do you think, Patrick?
I'm going to see it rise.
Yes. The balloon is rising 100 feet every second. Yes? Oh, this is a good one. State the domain of the graph. So let me ask you a question. Realistically, do we know where a balloon will stop rising?
No.
Or when it will stop rising? So can we assume that we would draw an arrow at the end of that line? Yeah, it's going to keep going. So let's talk about our domain. Okay, domain is time. So what is our initial time? Our initial amount of time here? 0 seconds. So our domain starts at 0 and it goes to what?
Infinity.
Infinity. So be 0 to infinity. Okay, so 0 less than x less than infinity. Now, I don't want to be equal to. Okay, so what's another way that I could write this? What's another way I could write that domain? Can I write like that? X is greater than or equal to 0. That implies it's just going to go on forever. We don't really know. Okay, either way I would accept that. Okay, so look at that. Any questions? Next one. All right, example. Okay, this kind of explains your slope and your y-intercept. Okay, in real world problems, which we've already talked about. All right, example 2. The graph for a stable that charges a $20 flat fee plus $10 per hour for horseback riding is shown below. So let's break this down. If they charge a $20 flat fee, how many times do you pay that flat fee? One time. Okay? And then $10 per hour. So you're going to pay the 10 multiple times, assuming that you go for multiple hours. Yes?
Yes.
Okay. So if you look at those two numbers, which one do you think would be your y-intercept?
20.
then 20 because it's one time. It's kind of like a starting point. Okay, and then $10 per hour. So if you look at your graph, that's reflected in the graph. It starts at $20, okay, and then it goes up $10 every hour. So our slope is the $10, and our flat fee is the 20, or the y-intercept, right? So write the equation.
Do you know what this $3 on there, or?
You can if you want to. All right, so our equation of our line, $10 times X hours plus that $20 initial fee. So if you go for 0 hours, how much money are you going to pay?
$0. $20.
20, okay? So you're kind of like, why, right? But think about it. If you go to a business and they say, oh, it's $20 to sign up, and then $10 every month. I don't know, maybe it's a gym membership, okay? So you go to sign up at a gym and they're like, all right, so pay $20 initially, and then you'll pay $10 every month. What do you think that $20 is for? Maybe just the cost of paperwork or the cost of, I don't know, maybe the staple thing, maybe that $20 flat fee is kind of like the cost for hay. I don't know. Okay, but they're taking $20 for some reason and then adding that 10 each time. So if you still rode 0 hours but you signed up, you paid $20. All right, so interpret the y-intercept. They kind of told you this in the direction. It's that $20 flat fee. Because you're going to pay that no matter what. And then interpret the slope. $10 every hour that you ride. Okay, is the number of hours capped? Like, will the number of hours that you ride stop?
No.
No. So we can assume that there would be an arrow on the end of that graph. I want you to see if you can write the domain. You agree? Or you can write it either way. So it should be kind of the same domain as last time. So the number of hours isn't capped. Okay, part F. How will the graph change if the staple changes its flat fee to 45 and it's $30 per hour? Just think about, before we write the equation, how would the graph change?
It would start at 45.
It would start at 45. What were you going to say? It'd be steeper, right? It's going to go up 30 as opposed to 10. Okay, so it'd be a steeper graph. Okay, and it would start at a y-intercept of 45. All right, if we write that equation, what's our new slope?
30.
Yep. And the flat fee would be 40. Okay, what questions do you have? Hanging in there? Yeah, okay. Example 3, the cost of a school banquet is $95 plus $15 for each person attending. Write an equation that gives a total cost as a function of the number of people that attend. I want you to see if you can fill in A and B. Do A and B all on your own. Okay, so slope y-intercept and write the equation. A and B all on your own. Okay, somebody raise your hand and tell me the slope. 15. And our y-intercept?
95.
95. Okay, so the 95 is happening one time. So whatever the y-intercept is, one time. The slope is something that happens over and over and over again. All right, the equation then should be y equals 15x plus 95. All right, so raise your hand. Interpret what that y-intercept of 95 means. What does that 95 mean?
Like 95 is to enter the banquet.
Okay, so not to enter the banquet,
Food.
just to have it. Okay, so 95 just to have it. Okay, somebody raise your hand. Ooh,
Yeah.
wrong spot. Shift it over. That was easy change. Okay. What about the slope? What does the slope mean? What does the slope mean?
$15 per person.
$15 per person. Okay, we're gonna pause right there, and I want to talk about what would this $95 go to if somebody was holding a banquet. Like why? Like for example, if we had to have it to school, why would the school charge you $95?
Catering.
For all of the stuff they have to do,
Okay, catering food.
all the stuff they have to do.
Okay, so staffing. They have to pay staff. Decorations. Okay, awards. Okay, so the food, I think, goes more for slope. Because if somebody charged $15 for each person, what else would that $15 go to except for food? Does anybody have any ideas? Probably food, right? If you think about like a meal costing about $15, it's probably about accurate for like a banquet meal. Okay, so we'll go ahead and say the slope would be for food. If that 95 would be to pay staff, it would be for decorations, for awards. All right, the domain. So this is a little bit weird because we don't see a graph. What's one way we could see a graph? Decimals. Okay, we could put y equals 15x plus 95 into decimals. But think realistically. Can you have zero amount of people at the banquet?
Oh yeah.
You could, right? How much money would you pay if you had 0 people at the banquet? Yes, you would. Okay. Is there a max? Did they tell us if there's a cap on the number of people you can have? No. So we're going to say our domain would be from 0 to infinity. Oops. And you can say x greater than or equal to 0. How would we find a cost for 77 people? What would we do with the 77? Plug it into x. So take your equation, and you're going to plug 77 in for x. And we're going to have to put that in our calculator. All right, that would be $1,250. So to do that question, you have to know which variable is people. Okay? Well, if you think about it, it's $15 per person. That's how we know that x is the number of people and y is the cost. All right, last part of this one. How many people attending the banquet, or how many people would attend the banquet if the cost is $245? Yeah, plug it in for y. You're going to do 245 equals 15x plus 95, and you're going to solve for x. I want you to solve for x on your own. You know how to do that already. I'll give you just a second here to solve. So 10 people, which the banquet, that's what the cost is $200. How you feel on that? Feel okay on that?
Yeah.
Okay, these last two problems, part F and part G, those kind of questions are going to happen a lot. So make sure you know and you're being aware of when we're plugging things in and where we're plugging them in at. All right, Maria charges $15 for every 2 hours she babysits. Fill out the following table below. So if she charges $15 every 2 hours, how much money is it going to be for 4 hours?
30.
30. What's next?
40. 40.
Oh, yeah. $60, $75. All right, go ahead and graph on the right-hand side. I would say that this is going up by 10, so be careful about when you're graphing. All right, there's a couple options for finding the slope. You can do slope formula with your table, or you can do rise over run. What do you think is easier? Probably rise over run. All right, so how much are we rising from here to here? What's the rise there? 15. And what's my run? 2. Okay. 15 over 2 is? What's 15 divided by 2? All right. So, we know that it's $15 for every 2 hours. What does the 7.5 mean? That's per hour. So she's actually charging $7.50 per hour. Okay, but they did it in terms of 2 hours at the beginning. So if we do our equation, it'd be y equals 7.5x. What's the y-intercept? 0. Now we don't see that in our table, but we can see here if we extended our graph, it's actually at 0. What does that y-intercept mean in terms of the problem? $0 for 0 hours. Okay, so she doesn't charge a flat fee. She just charges per hour. So there's no flat fee. No babysitting. No money. No babysitting, no money. All right, slope. You just told me 7.5 means what?
The cost per hour.
The cost per hour. Okay, state the domain. What is the least amount of hours that she can work? 0 and the most? We don't know, right? So we'll say infinity. You can write it either way. Over the summer, she babysits for 20 hours a week. How much will she make each week? Let's go ahead and use our equation. Right? I'm going to plug 20 in for x because x is the number of hours she works. All right, 7.5 times 20. Anybody do it in the calculator yet? What is it? 150? So she's making $150 per week. Is that a lot? Does anybody know what minimum wage is? Okay, so babysitting, she's actually charging less than minimum wage. So I don't think it's that great of a person. She needs to up her wages. All right, we're gonna go ahead and do a couple OST, and I'm gonna let you practice. These are both released questions. These were on the OST the last few years. A shipping company charges a cost per pound plus a fixed fee to ship a package. The total cost in dollars of shipping X pounds. Okay, this is important. Okay, they are telling you that X is the number of pounds. Okay, is modeled by the function y equals 499x plus 5.75. Which part of the function is the fixed fee? 575. Okay, remember, fixed fee or flat rate is y-intercept. Okay, every single time. What would the 499 be? That would be the slope. Okay. All right, Emerson has $120. Each week he saves an additional $15. Write a function that models the amount of money he has after X weeks. What would be the slope of our function? 15, because it's going up 15 each week, plus his initial $150. All right, the back is practice, so go ahead and work on those 3 problems. We're going to talk about it before you leave today. We have about 10 minutes to work, and then the last 5 minutes we'll go over it.